Hi everybody, so this is a two-parter for problem set 65. We're looking at addition of radical expressions as well as weighted averages. What's really cool about this is that there really is a close connection to like terms when you're adding or subtracting radical expressions. So let's take a look at this first example where we have 4 times the square root of 2 minus 5 root 2 plus 12 root 2. Now, one of the things that I notice is that each of these values, 4, 5, negative 5, and 12, are all being multiplied by root 2. So what that means is that since they are like roots, they can actually be subtracted from each other. So let's look at how that works. So the first thing that I'm going to do is start out with 4 root 2 minus 5 root 2. So 4 minus 5 is negative 1 root 2. And I'll add the 12 root 2 as well, because we haven't dealt with that yet. So now we have negative 1 root 2 plus 12 root 2, and now we can add the negative 1 and the 12 to get 11 root 2. So, like I said, these are like, very similar to like terms, and kind of have a little bit of a root in the distributive property, and I just want to kind of demonstrate how that works with this first example kind of backing up a little bit. You could imagine that if we started out with 4 root 2 minus 5 root 2 plus 12 root 2, if we factored this, reverse distributed, we could actually factor out a root 2 because each of these values is being multiplied by root 2. And what that would look like is root 2 on the outside, and then 4 minus 5 plus 12. If you simplify everything inside, 4 minus 5 is negative 1 plus 12 is 11. And that's still being multiplied by root 2. So you could say, yeah, this is the same as 11 times root 2 with a commutative property there. So again, kind of bringing this back to factoring in the distributive property. All right, let's look at this second example. Now what's different about this one is that I noticed that I don't have like roots. Yeah, we have 4 root 3 plus 3 root 5 minus 6 root 3. And the root 5, we really can't combine that with the root 3's. So what I like to do is I like to show kind of that, just that step of moving like roots together. So I did 4 root 3 minus 6 root 3 plus 3 root 5. And again, that's just putting these root 3's next to each other. 4 root 3 minus 6 root 3 is going to be negative 2 root 3 plus 3 root 5. And at this point, we really can't do anything else and have a precise answer, so this is going to be what we have. All right, similar situation down here. We don't have all like roots, but we do have pairs of like roots. So I notice I've got root 2's and I've got root 3's. So the first thing I like to do is I like to just rewrite these so that my like roots are together. And now I can combine my root 2's. So negative 3 root 2 minus 2 root 2 would be negative 5 root 2. And 5 root 3 plus 8 root 3 would be 13 root 3. Again, at this point, we don't have like roots, so this is as good as it gets. All right, let's take a look at weighted averages. So down here, we have a weighted averages question. Jim's scores were 60, 70, 80, and 90. What is the weighted average of his scores if the tests were weighted 1, 2, 4, and 6 in that order? So what's really important to recognize here is that we need to, I'm going to kind of write the steps here on the side. We need to multiply each score by its weight. And this hopefully makes sense because when we weight something, we're saying, okay, heavier the weight, the more important the value is. We're calling it in the segment. The next thing we're going to do is we're going to find the sum of these products. And then finally, we're going to divide by the sum of the weights. All right, so what does that look like? Well, multiply each score by its weight. Well, it says that we have these scores and we say that they're weighted 1, 2, 4, and 6 in that order. So that means that 60 times 1 is the weight that goes with the 60. I'm going to sum that. So sum of these products. So 60 times 1 plus 70 times 2 plus 80 times 4 plus 90 times 6. And finally, I'm going to divide that by the sum of the weights. So 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 6 is 13. So now I'm going to go ahead and I'm going to evaluate this expression. So I got 60 times 1 is 60, 70 times 2 is 140, 80 times 4 is 320, 90 times 6 is 540, all over 13. Now I got to add these together. 200, 520, 520 plus 540 is 1060 over 13. And now I'll do a little bit of division over here. Like a little long division. I think 13 goes in 106 8 times. I need to give myself a little more room here. Let's see. 104. Hey, that's pretty good. Subtract that out, bring down the 0. 13 goes into 20 once. So, oh, I got myself in trouble again. Can I just pick this up? Let's see. Whoa, uh-oh. It's a little trippy. Alright, I'm just going to have to erase this part. Give myself a little more room. And so now we're at 13. Subtract that and the 7. Looks like we're at 5 here to get to 65. 13 goes into 50 3 times. And I think I can just leave it right here. I'm going to call it 81.5 as my weighted average. Again, after you've gone through this, make sure that it makes sense. 81.5 kind of falls within these scores, and it makes sense that it's a little bit on the higher side since 90 has so much weight behind it. So there you go. Let's take a look at another weighted average question. All right, so in this example, we have percent weights. So in the course that Joan was taking, each of 3 tests were weighted 20%, and the final paper was weighted 40%. Joan's test scores were 60%, 70%, and 80%. She earned a 60% on her paper. What was her final grade for the course? I guess I should say what was her grade for the course. This is much simpler than the other, I would say. Pretty straightforward here. You just have to multiply the weight by the score and add the products. So what does this look like? Well, I know that each of these tests, 60%, 70%, and 80%, they're at a 20% weight. So I'm going to take that 20%, convert it to a decimal by dividing by 100, and I'm going to multiply each of these tests by 20% changed to a decimal, which happens to be 2/10. So 60 times 0.2, 70 times 0.2, and 80 times 0.2. All right, and then she's also got that final paper, which is 60% was the score, and that's weighted at 40%. So that would be 0.4, 4/10. And now I need to do all of this calculation here, so I'm going to go ahead and do that. So 60 times 0.2 is 12. 70 times 0.2 is 14. 80 times 0.2 is 16. And 60 times 0.4 is 24. So I'm going to add up all of those values, and what I get is 6, 12, 16, carry the 1, and 4, 6. So 66 would be her overall grade. Again, kind of do a gut check to say, does it make sense? Yeah, she took a bunch of tests, 60, 70, and 80, that were equal weights. Here into 60 on her final paper makes sense that it would be just a little bit higher than 60. So take a look at these practice problems. Give it a shot.